Today's lesson is how to find perimeters. The first thing that you need to write down in your notes is the word perimeter. We're going to break it down into Greek and Latin so that we can really understand what this means. The first thing we need to notice is that it's really composed of two Greek and Latin words, peri and meter. Peri means around, like a periscope is a tool that lets you look around above the surface of the ocean in a submarine. And meter means measure. And sometimes it's not meter, it's metra. So sometimes it's that too. Make sure you've got all that written down. So now that we know that perimeter is composed of those two words, meaning around and measure, if we flip-flop the order of them, we've got to measure around. So basically, perimeter comes from Greek and Latin, meaning the measurement around a two-dimensional shape. Let's start by reviewing the fourth grade concepts of measuring the perimeter, or the distance around polygons. So you learned that polygons are made of line segments. Write this down. That they have at least 3 sides. And that they are two-dimensional, 2D, also known as plane figures, because they lie flat on a plane. Not an airplane, but a plane meaning a flat surface. So let's review finding the perimeter of polygons. If you have a square and one of the side lengths is 2 inches, based on what you know about squares, that all 4 sides are the same length, basically what we can do for the perimeter, the formula for the perimeter of a square would be P equals 4S, or perimeter equals 4 times the length of one side, because it has 4 sides. So 2 inches times 1, 2, 3, 4. Or side plus side plus side plus side. Lots of different ways that you can chunk that and group that. I think for this square, the most efficient thing would be to say 4 times 2 inches would be 8 inches. They're just regular inches because we're just measuring from one point to another. We're not measuring the area inside. We're measuring around. Around. All right, so what if we have a rectangle? I put hash marks on there to show that these opposite sides are in fact the same length, and these opposite sides are the same length. And because my angles were a little messed up, but it's the magic whiteboard, I put in the 90-degree right angle sign so we know this is a rectangle. So if we want to find out the perimeter, we really only need to know the length of the 2 different sides. Let's say the longer sides are each 16 feet and the shorter sides are each 8 feet. So in this case, the perimeter equals side plus side plus side plus side, or other ways that you can group it, you could do 2 of the lengths, 2L, and then add that to 2 of the widths. And that might be a more friendly way of doing that with mental math. So let's try that. By chunking that, we have our 2 lengths measuring 32 feet total and our 2 widths measuring 16 feet total. Now we just need to add those together and we'll get our total measurement around our perimeter. In this case, the perimeter is 48 feet. So you can think of just adding 16 plus 8 plus 16 plus 8, or you can do twice the length plus twice the width. Some people even like to add this up. 16 plus 8 is 24, and then double it, another 24, to get the 48. The nice thing about addition is it's commutative, so you can rearrange the order of the side lengths any way that you would like, as long as you are remembering that perimeter means measuring around. All right, now we're going to get into some words that might be unfamiliar when it relates to math. We've got regular and irregular. When that relates to math, it means regular polygons have side lengths that are all the same length, and all of the inside angles are also the same. Same side lengths and angles. Irregular, going back to Greek and Latin again, ir means not. So irregular means not regular. Sometimes, depending on the root word, it'll be ir, sometimes it's ill, and sometimes it's in, but that all means not. So if it's not regular, that means it does not have the same side lengths and the same angles. So a regular hexagon would look like this. Okay, I tried. It's very hard to make them all the same side length, so I'll draw hash marks to show that it's all the same side lengths and all of the angles have the same symbol as well, showing that all the angles are the same. So regular would look like that. An irregular hexagon would look like this. Pretty wacky. It still has 6 sides though, so it's still a hexagon. You can play around with some other irregular hexagon shapes as well. The great thing about knowing what regular means is this. If you know that you have a regular shape, all you need to figure out the perimeter is one side length, and you can figure out the perimeter of the entire figure as long as it's regular. So let's say that one side length of this magical whiteboard regular hexagon is 7.9 centimeters, or 7 9/10 of a centimeter. We could figure that perimeter out by adding up all of the sides. 7.9 plus 7.9 plus 7. Okay, there's got to be a faster way. A hexagon has 6 sides because hex or hexa means 6. So basically we have 6 groups of 7 9/10. Yeah, it's a multiplication problem. And if I solve that multiplication with the traditional algorithm, I can compensate by changing the 7.9 or 7 9/10 factor to 79, moving that decimal basically by multiplying by 10, compensating by multiplying by 10, and now solve it the regular way. 6 times 9 is 54, so a 4 can go in the ones place, and I can carry the 50 by writing a 5 in the tens place. And then 6 times 7, which is really a 70, because we're going to be working here in the tens place. So 6 times 7 is 42, it's written on my teacher's shoe, plus 5 more would be 47. So that means 47 tens, or a 4 in the hundreds place, and a 7 in the tens place. But remember, we cheated. We compensated by multiplying by 10 once, which means we need to cheat back by dividing by 10 or moving the decimal one place over. So 47.4 or 47 4/10. But what's the label? Centimeters, not square centimeters, because we're just measuring from one point to another to another. The measurement around. Not what's inside, around, just those straight lines. There are other neat tricks and shortcuts for perimeters of other polygons as well. For example, a rhombus. A rhombus, by definition, has 4 of the same side lengths as marked with the hash marks, and the opposite angles, meaning the angles across from each other, are the same. But all four angles aren't necessarily the same as each other. They could be, but they don't have to be. So we have these two angles that are the same and these two angles that are the same. But all the sides are the same. So all you have to know to find the perimeter of a rhombus is one side. If one side of a rhombus is 2 meters, then multiply that by 4 or do 2 plus 2 plus 2 plus 2, and you've got 8 meters for your perimeter. A rhombus is not a regular polygon because not all of the angles have to be the same. A square is a special type of a rhombus that happens to be regular because not only are all of the sides the same, but all of those angles in the corners are the same too. So a rhombus is not considered regular because the angles aren't necessarily the same. But the sides are, so our little 4 groups of the side trick works. Let's take a look at some triangles. This is an equilateral triangle. An equilateral triangle will have 3 of the same side length and all 3 angles are the same. Lat or lateral means side, and equi means equal, so equal sides. And tri, of course, means 3. So all you have to know is the length of one side. Say it's 2 millimeters, so 2 times 3, for a grand total of 6 millimeters. With an isosceles triangle, we know that it's going to have 2 sides that are the same length and 2 angles that are the same. So all we have to know is the length of the base and then one of the sides that's the same length as the other. So we know we have 4 plus 8. And this one, well, with this mark, it means it's the same. So 8 again. So perimeter is side plus side plus side for a grand total of 20 inches. There's one more cool polygon that has some tricks to it. We know that a parallelogram has sides that are parallel to each other if they're opposite, and they're also the same length. So these are opposite sides, meaning across from each other, and they're the same length, and these opposite sides are the same length. The other cool thing that's about parallelograms is that opposite angles are the same as each other. So for a parallelogram, all we have to know is the lengths of 2 of the sides, and we have enough clues to figure out the entire perimeter. So we know that we have 2 sides that are 5 5/10 and 2 sides that are 1 8/10 yards. So you could add them all up like that. You could also do 2 times 5 1/2 and group those together first, plus another 2 of the 1 8/10. Either way, you should get the same answer. Go ahead and hit pause and figure out your answer with whichever strategy you'd like, and then hit play and check your answer. And there's another way of solving this too. Just like with the rectangle, some students might choose to figure out this total and then double it. So they would do 2 times whatever the total of these 2 sides is, 1 8/10 plus 5.5. So do this first in the parentheses and then double it, and that'll still get 14 6/10 yards for the total perimeter. Task time! Dun, 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 dun. This task has 3 parts. For each of the following shapes, you need to draw a model and find each perimeter. So I'm going to give you descriptions with words. You need to take those words and draw a picture of what that would look like and find each perimeter with a strategy that works best for you. Work hard, and you'll share your work tomorrow.